So you're welcome back. Now from our previous videos, we saw that the current flowing through here into this rectifier, right, IA, into this looks like that. Alright, and then the current flowing through this diode, one of the diodes, D1, right, looks like this. Okay, please play the previous videos. Now, if you want to now calculate the average value and RMS value of this diode current, ID1 RMS and the ID1 average, which is your IDC. Now, you follow the same pattern, what we did before, how to derive the average value and the RMS value. You consider here, you just make sure you split this, and we know that from here to here is pi over 6. So sorry, I'm dealing with this. From here to here is pi over 6. So you just do that average value of this times 1, 2, 3, 4. And that's all for one cycle. Did you get that? Right? So with that, you should be able to get that the average value or average DC value of the current that is flowing through the diode is just the same thing as IODC divided by 3. IODC divided by 3. Remember that IODC is this DC divided by the resistance, right? Okay, so if you know already, if I know, if I divide by resistance, I'm going to get something that looks like that also. Alright, as IODC. So if I take that and divide by 3, alright, then that will give you the current flowing through this diode. So in other words, if I want to get IODC, I just multiply current flowing through here by 3. Okay. Now that's by the way. And then if you want to get the RMS value, you do the same thing, follow the same pattern. Okay, you must watch the previous video, and then you'll be able to get that RMS value is the same thing as saying just what we have here, IO RMS over 3, find the square root of that. Okay, the square root of 1 over 3. Oh, sorry, that put. Sorry, if you get it, if you prove it, if you just want to derive it, you can derive it. 1 over 3 IO RMS. Okay, we give you the RMS value of the diode current. Now, also, if you want to calculate this RMS value of this signal, remember, this signal is AC signal. If you look for the average value, you will get 0. Okay? Because what you get here is the same thing there. So you get 0. But the RMS value, you will get a value. Okay? So if you also apply the same method for RMS value, okay? Now you are going to get that IA, which is your source current, IS, okay, is same as 2 over 3 will give you 2 over 3 multiplied by IO RMS. RMS. Okay. So we should know these formulas very well, alright, because we use that to solve problems. There are some other things that we need to know. Some other factors that we need to know. Things like your apparent power. We know apparent power. Power in here, S is √3 IVLL, right? So you know that this is your IS, which is this IS that we have here. That's your apparent power, okay? And remember your peak inverse voltage. This is a peak voltage, and this peak voltage should be also, when this is not conducting, when any of these diodes are not conducting, they should be able to withstand that peak voltage. That's what we call it, peak inverse voltage. So peak inverse voltage is √2 VLL. When a diode is reverse biased, it should not, it should be able to block such amount of voltage. Okay, the peak of that. Okay, or the peak of the RMS value from AC signal, the peak of this. Okay, did you get that? And then we also have what we call transformer utilization factor. Transformer utilization factor. Now in this case, you are comparing the output power with your input power, but the output is DC, right? So if I have PDC as my output there, now you divide it by your input apparent power, the apparent power for the three-phase, right? This is root 3 ISVLL. So by the time you compare that, we call that transformer utilization factor. And then we also have input power factor. What is that? Now, if I can take the RMS of this and divide by the RMS of that, now that is what we call input power factor. Okay? So input power factor will be IO, will be PO RMS. If I get PO RMS, right? PO RMS by P in, but in this case it's an apparent power. S in, okay? S on the three-phase. So, in other words, when there are two kinds of output, right? Output here we have DC output, we have RMS output. So if I take DC output and divide by that, then I'll get transformer utilization factor. But if I get the RMS output and divide by power in here, then I will get what we call our input power factor. Okay? And then we also have rectification efficiency. We want to see whether we're able to get a straight line, because we want to get a straight line, but this is not straight. Right? They see some ripples, RMS ripples. So if I can take the DC value and divide by the RMS value, then that gives me my rectification factor. Okay? So rectification efficiency, right? Efficiency. I'm just checking what is happening here. So I'm going to take the PDC divided by P RMS, right? So I have PDC over P RMS. So that is a rectification efficiency. Okay, did you get that? All right. So now just watch out for the next video, which will be problem solving. Okay. Thank you.